Hi students, in this video we will be solving question number 3 from the exercise 10.1 from the chapter straight lines. This is a chapter from first PU syllabus. Go to playlist and look for straight lines. In that you will be able to find all the sums and derivations related to this chapter. Okay, now let us solve the question number 3 and the question is like this. Find the distance between point P of x1 comma y1 and Q of x2 comma y2 when PQ is parallel to y-axis and PQ is parallel to x-axis. There are two cases in which we have to find the distance of the points P and Q. So first we will consider rectangular coordinate system. Then we will consider point P and Q. So this is point P and this is point Q. And we could have considered this P and Q here also. That is to the left side of the y-axis. Okay. Now we will join these two points P and Q. We have to find the distance between these 2 points. If we were to consider P and Q here also, we would get the same distance. Now we have to find the distance. We know a distance formula that we already have learnt in our high school, which is square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the distance formula. Now what is the equation of y-axis? It is y equal to 0. This you have already learnt. You consider any point on y-axis, the x-coordinate will be 0. Similarly, you consider any point on a line which is parallel to y-axis, the x-coordinate will be same. That is, let's say this is x equal to 2. A point here will be 2 comma y1. Point here may be 2 comma y2. 2 comma y3. Only y coordinate changes, but the x coordinate remains same throughout on this line. Is this clear? The line PQ may be here. X coordinate in this case would be negative. So x coordinate, let's say if it is minus 3, throughout any point on this line will have the coordinate as minus 3 comma a variation in y value. Is this clear? So when PQ is parallel to y-axis, x1 is equal to x2. X coordinate is same. So we are going to apply this for the distance formula. So PQ is equal to square root of x1 minus x1 whole square plus y2 minus y1 whole square. So this will be 0. This you could have written as x2 minus x2 whole square also. Okay. So this anyways will be 0. Then it is only square root of y2 minus y1 whole square, which will be modulus of y2 minus y1. Why did we consider modulus? Because we are talking about the distance. This value when after simplification may be negative, but distance cannot be negative. So we are considering the modulus, which gives us the value or the distance. So the distance between point P and Q when PQ is parallel to y-axis is modulus of y2 minus y1. Now let us consider the second case where PQ is parallel to x-axis. This case also similar to the very first case, but what we have to consider is a line parallel to x-axis, then y coordinate will be same throughout for any point on that line parallel to x-axis. Okay, let us again consider rectangular coordinate system. We are considering 2 points P and Q here. This after joining we will get a line which will be parallel to x-axis. This point we could have considered here also. Then we would have got a line parallel to x-axis like this. Then any point on y-axis, any point on this line parallel to x-axis will have a y value which is going to be a constant. Any point on this x-axis, the y value will be 0, right? Similarly, any point here, let us say if the y value here is 2, then throughout this line, for any point, the y coordinate will be 2 only. Only the x coordinate will vary. So what we are going to write here, y1 is equal to y2. The line can be here, okay? The line can be here. Then y will be negative, that's it. But it will still be constant for all the points. So we are applying this condition here. Again, distance PQ is equal to square root of x2 minus x1 whole square plus y1 minus y1 whole square. We could have also written this as y2 minus y2 whole square because they both are equal. So this whole term will be 0. Then we'll be left with PQ is equal to square root of x2 minus x1 whole square, which is modulus of x2 minus x1. PQ is equal to modulus of x2 minus x1. Similar to the previous case, we are talking about the distance. Distance cannot be negative, so we have considered modulus of x2 minus x1. Thus, the distance between point P and Q when PQ is parallel to x-axis is x2 minus x1 with modulus. Hope this is clear, children.